Hello, guys. We are here with our first lesson on air and aerodynamics as we look into our new science unit. So we're going to hit the ground running, and we're going to look at the 6 properties of air that really show us how air interacts with the world around it. So first off, air is a fluid. Now, fluids can be both a liquid or gas. When you think of a fluid, normally you think of something like a liquid, like water or oil or anything that we have seen that flows. Their molecule positions are not fixed and they can move or slide past each other. They take the shape of whatever container that they are in. If you throw an ice cube into a jar, it doesn't magically take the shape of that container because it has a fixed shape. Fluids, both liquids and gases, don't have that fixed shape, and they can pour into a jar and take the shape of that container. Fluids move from areas of high pressure to low pressure. If they're experiencing a lot of pressure in one area, they will actually move over to another area so that they can even out that pressure. Pressure or temperature changes can cause density changes. Warmer air expands and is less dense. Colder air contracts and is more dense. And warm air, because of that, warm air rises because it is less dense than cold air. That's why if you have a 2-story house or you're in a very tall building, if you go upstairs during the day, it's much warmer upstairs because the heat has warmed the air. That warm air has gone to the top of the house, and the cold air has settled in the bottom. That's why it's colder in basements as well. Second property of air is that the air is made up of several different gases. Now, we breathe in oxygen. The 2 main gases we've talked about are oxygen and carbon dioxide because of our trees and forest unit. But really, it's a mixture of many different gases, even some so small we won't mention them here. But they're made of a mixture of gases like nitrogen, oxygen, and argon with traces of water and carbon dioxide. Oxygen is needed for combustion, oxidization, and burning, also breathing. Carbon dioxide is heavier than most gases and therefore sinks. When we say heavier, we mean denser. If you had a jar of carbon dioxide and the same amount of oxygen, carbon dioxide would actually sink and be heavier if you had that same amount. Think of carbon dioxide being like a solid iron stone or brick, and a oxygen being or say even helium, because that's much lighter, that we see in balloons, being a sponge. Even though you have the same volume, the same amount, the brick is heavier and it's more dense. So air also takes up space. We can tell that when you blow up a balloon, you can see that that air is taking up space. And it provides the shape for objects like basketballs, footballs, rugby balls, and balloons. The amount of space that air takes up can be measured and recorded, such as measuring how much air is in a balloon. Property of air number 4 is that air has mass. So when we say air has mass, we're really talking, or normally we say air has weight, but when we talk about air has mass, it's about the actual particles that make up air. Air has weight and its density can change, so how tightly the molecules are packed together. A bottle filled with water is heavier than a bottle filled with air because water is more dense. A balloon filled with air will be heavier than an empty balloon, and that's an experiment we'll actually be checking out. So think about what happens to air at sea level versus air at the top of the mountain. Is there the same density of air in each place? Think about any video you've seen of people climbing, say Kilimanjaro or Mount Everest. The air is less dense up there. There is less air up there, and they need oxygen tanks because there's just not enough oxygen up at the top. Property number 5, air can be compressed. Air can be compressed or squished into smaller spaces by forcing molecules to be closer together than they normally would be. Molecules that make up gases are far apart, so they can be compressed using pressure. Think of anything from hairspray to spray paint to soccer balls. And finally, when we do compress that air, and even when we don't compress that air exerts pressure. It pushes on objects. When it's compressed and due to the weight of the gases we have in the air, we have atmospheric pressure, or because of the mass that air has, atmospheric pressure is the weight of the air above you, and it puts the pressure on your body all the time. we are actually having, just by the column of air above us going up into space, we have about a metric ton of air pushing down on us all the time. That's why we can't stand up for an infinite amount of time. We eventually get tired and we have to sit down. We have a metric ton of air pushing down on us, but our bodies have the ability to withstand that because we grew up in this environment. If you go to another planet that had denser air and more pushing down on you, it would be harder to walk around because you'd have more weight pushing down on you. Humans have evolved to handle this atmospheric pressure, in part to having air also inside us that balances out that pressure. So that's a quick introduction into the 6 properties of air that we see around us all the time, but we don't necessarily take notice of. So in the future video, I'll be showing some experiments that demonstrate these properties of air, and I'll even be trying to do some of them live. Thank you very much, and if you have any questions, please feel free to email me, and we'll talk to you soon. Bye.